Hi students, now we are going to understand how to find the average velocity of the gas molecules taken in a container. So here I have considered 6 molecules for example. So there are so many number of gas molecules actually in a container. I have shown only 6 molecules whose individual velocities are V1, V2, V3, V4, V5 and V6 maintained at a temperature T. Now how to find the average velocity is very simple. Just like how do we find the average of 6 numbers only. So this is represented by the symbol V bar. So the average velocity is just the average of these given velocities. So I add the velocities V1 plus V2 plus V3 plus V4 plus V5 plus V6. I am adding all the individual velocities and I divided by the total number. The total number here is 6. In general, if there are n number of molecules means it is extended. So here it is extended up to Vn. Okay, and you have to divide it by the total number of molecules. So this is the expression for the average velocity. Now let us assume that V1 is equal to 1 meter per second and V2. These are all different velocities of the individual molecules. So I have taken V1, V2 and V3 and V4 is 4 meter per second. These are for example I am taking. These are not the actual speed will be in centimeter per second and here this I am taking in meter per second. So this is a 5 meters per second and V6 is what 6 meters per second. So how to calculate the average velocity? Therefore V bar is equal to what? 1 plus 2 plus 3 plus 4 plus 5 plus 6 whole divided by 6 number of molecules are there. So I have to add the 6 velocities and divide by 6. So now you can see that 6 plus 4 10, 10 plus 5 15, 15 plus 3 18, 18 plus 2 20, 20 plus 1 is what 21. So this is now equal to 21 divided by 6. So therefore average velocity is equal to what? 21 divided by 6. 21 divided by 6 is equal to 3.5 meters per second. So this is how to find mathematically the average value of the velocity. But in terms of temperature, pressure and volume and the molecular mass or molar mass, how to find out. So here there is expression that V average is equal to square root of 8 by pi k into T by m, small m. So whenever I use this Boltzmann constant k, the denominator will be small m, that is what mass of one molecule. Suppose if you take 1 mole, then this also can be written as what? Square root of 8 by pi. Keep it in mind, 8 by pi. So kt by small m is now replaced by RT divided by capital M, where capital M is what? Mass of 1 mole of a gas. Small m is molecular mass, capital M is molar mass. Okay. So this RT is also equal to P into V. So this also can be written as what? Square root of 8 by pi into PV divided by M. So this can be written again square root of 8 by pi. This P is retained in the numerator and the denominator I can bring this volume as M by V. So that mass by volume can be replaced by what? The density of the gas. So this is also now equal to what? 8 by pi into P divided by density rho. So these are all the different expressions to calculate the average velocity of the gas. This is direct method if you know the individual velocities. Suppose if you don't know the individual velocities means by formula we can calculate. So this 8 by pi also equal to what? 8 divided by pi is nearly equal to 2.5. Therefore, I can also write this average velocity V bar is equal to square root of 2.5 RT divided by m. Like this also I can find out that. So if I compare this with the RMS velocity of this molecules, if I compare the RMS velocity of the molecules, then what V RMS is equal to square root of 3 RT by m. So this is square root of 2.5 times RT by m, and this is what square root of 3 RT divided by m. So which is greater? V RMS is greater than V. So therefore V RMS is greater than this V average. Now children, here by this method I have found the average value, isn't it? Now by this if I find the RMS velocity for this given value, of the velocities, if I find the RMS velocity means then I can go like this. V RMS is equal to square root of 1 square plus 2 square plus 3 square plus 4 square plus 5 square plus 6 square whole divided by 6. So this is how to find the RMS velocity by mathematical method. So this is equal to square root of 1 square is 1 plus 4 plus 9 plus 16 plus 25 plus 36 whole divided by 6. So that this is equal to square root of, see this 9 plus 1 is 10, 16 plus 4 is 20, so 20 plus 10 is 30, 30 plus 25 is 55. So this is square root of 91 by 6, square root of 91 divided by 6. So if you use the calculator, 91 divided by 6 is coming as 15.2. So this is the square root of 15.2. So now we go for the square root value of 15.2. So this is equal to, so this is a square root of 91 divided by 6 is equal to 15.2. So square root of 15.2, square root of 15.2 is equal to 3.89. So this is coming as what? 3.89. Therefore, B RMS is equal to 3.89 meters per second. So what is the value of V average? We have found is only 3.5 meter per second, and here V RMS is coming as what? 3.89 meter per second. So we can now accept that V RMS is greater than V average. Okay students, you must have understood how to find the average value of the velocity of the gas molecules. Fine.